So this is actually the AV calendar that's on the ASD website. So we are here on March 31st, which is an A day. Okay. So tomorrow's a B day, but it's an asynchronous day. So tomorrow for your B day classes, you will not have any like Zoom or Teams calls. You will just need to make sure that you are logging into all 4 of your B day classes on Canvas throughout the day, and completing whatever your teachers for your B day classes have put up there for you. And then Friday is a holiday, so that means there won't be anything new posted for any classes. You don't have to log into Canvas, all that stuff. But because that's a Friday, that means that next week Monday is an A day, and so that'll be a regular day. I'll see you guys here on Zoom for class, Monday, Wednesday, and Friday next week. But next week on the Tuesday the 6th and Thursday the 8th, those B days, those are star testing days. And so they originally told us that those were going to be asynchronous B days, and you guys would be kind of like you're doing tomorrow. You would just log into your Canvas for your classes for attendance and work, and you wouldn't have any Zoom calls. They just informed us at the faculty meeting that I was at about 15 minutes ago that that might be changing and they may not be asynchronous, but they didn't really give us a lot of details on what exactly that means. So I don't know if that means that they're going to be expecting us to still have synchronous classes on those days, even though we're testing. I can't imagine they would do that because all of the teachers are going to be helping with testing. So there's not going to be anybody available, to get on Zoom calls for their classes. I don't think it would be that option, but you never know. I don't know what the district decides to do sometimes. But the other option, if they're not going to make them asynchronous, I'm wondering if they're going to say for those B days that since they're testing days, that you're not going to be responsible for having to log into Canvas at all. So that's what they wouldn't be asynchronous. They would just be like, I don't know, like makeup days or something. I'm not sure exactly. So as soon as I hear more information clarifying that for next week, I will send out a remind and let you guys know. But just know that next week, Monday, Wednesday, Friday, all normal A days. We'll log on to Zoom. We'll have our synchronous time just like normal. But Tuesday and Thursday, they're star testing days. So whatever happens, they probably will not be normal. Okay. And so Tuesday is freshmen for English 1 are testing. You guys, since y'all are all sophomores, y'all have your English 2 test on Thursday the 8th. And so that means that you'd be coming up to school on the morning of the 8th by 7:35, and you'll be assigned a testing room to go to, and all the tests are going to be done on computer, they have told us, I believe. So there won't be any like papers that you'll have a Chromebook or a laptop or something that you'll be doing the test virtually or digitally, I guess, online. But you do have to come in person into the building for it. And so you guys, will be here on the 8th. On the 6th, you won't be coming here because the freshmanly testing. And so again, I'm not sure if you're at home, if they're going to be still expecting you to log into Canvas or not. And as soon as I hear clarification on that, I will let y'all know. That being said, next week, so see this little closed parentheses here on the 9th, that means that's the end of the 6 weeks. So I kind of have been talking about this for you guys for the last week or so, that, these last couple weeks, they're going to be weird because we have so many like asynchronous days, or we don't have class, or we have a holiday on Friday this week with star testing days next week. So there's a lot of time where you won't be seeing some of your teachers, especially B days. So make sure that you are like caught up with your classes, that you have your work turned in, or that you're at least communicating with your teachers. If you have stuff not turned in, send them a quick message in Canvas, or, if they use remind, and just let them know like, hey, I know I'm missing this, I'm trying to get it done, or whatever. Because as long as you're communicating, they're probably going to be more likely to work with you on, making sure you get everything done by the end of next week. Okay. Then on Monday the 12th, it is this little symbol means that it's a student holiday. Okay. So after next week, the 5th through the 9th, the 12th is a student holiday. So that means like you will not have to log into Canvas or have any Zooms that day. The last 6 weeks actually starts on Tuesday the 13th, and it's a B day. Right now, they are telling us that that is the week that if you choose to do in person for the last 6 weeks, that would be the day that you would start coming. Because if you choose to do in-person learning for the last 6 weeks, starting April 13th, you're going to be expected to come to campus for class every day, starting on the 13th. If you choose virtual, then you'll still remain at home and you'll just log into the Zooms and work on Canvas. But if you choose in person, you'll have to come into the building, and our classes will still be set up pretty much the same. We will still get on Zoom for the first part and go through our lesson or activities or whatever we need to discuss that day. And then afterwards, you'll be able to have time to work on whatever you need to work on Canvas. Okay. Um, there's not really any holidays after that because we're getting into May. I will say this week, May 4th, 5th, and 6th, those are more STAR testing days. None of them are for you guys. They're all for freshmen and juniors because it's Algebra 1, Biology, and US History. So you guys, after next week, you guys don't have another STAR test, but those days will probably be like some kind of weird asynchronous day, or like we won't have to log into class. We'll have to wait and see what they tell us. But just know that that's kind of coming up that first week of May. And then if any of you guys are testing or you're in like AP World History or AP European History, sometime here, I don't know the exact test days, but you'll have your AP test sometime in May as well. And then we get to the end of the year, we have exams on the 25th and 26th, and that's when we finish up. Okay. So I just wanted to kind of quickly kind of do an overview of that last 6 weeks, but really focus on the next couple weeks with like the holidays and the asynchronous days for testing and stuff like that. And just kind of remind you guys and clarify a little bit on those dates coming up. Okay. So for today's lesson, we are looking at gas laws. So I'm going to go ahead and navigate over here. So gas laws is your page for today. And so really it starts off with a recap of the properties of gases that we kind of were introduced to in the previous lessons. And so it just kind of reviews them for volume, pressure, temperature, and then it also talks about amount. And so when we talk about amount, we're talking about the number of gas particles, and typically we measure that in moles. And so we'll be talking about moles of a gas, just like we had moles in our last unit when we were talking about like molar mass and Avogadro's number and things like that. So volume, the amount of space a gas occupies. And so the volume of the container usually limits that, and we measure it in liters. Sorry guys, I got a phone call that I needed to take, but I'm back now. Okay, so just kind of pay attention to some of the units here, like volume is liters. Pressure, we talked last time about how it can have multiple units. So common ones are going to be atmospheres and either kilopascal or Pascal. But there's some other ones that we talked about last time as well, like pounds per square inch, torr, things like that. And then temperature, we talked about, it's actually the measurement of average kinetic energy. So it's how measuring how fast the particles are moving, how much energy they have. And so for gases, remember, we always measure it in Kelvin. So if you're given a Celsius temperature, you have to convert it to Kelvin before you can use it for any kind of gas questions. Okay. So this is just asking you to kind of remember from last class, that simulation, you looked at the effects of pressure, volume, and temperature on each other. You know, when you kept one of them constant, what would the other two do in relation to each other? And so when you're looking at these relationships, number of moles is usually kept constant. And so the three laws that we're actually going to talk about today, sometimes they're kind of called like the ABCs of gases, because they have their names all start with ABC. So you have Avogadro's law, Boyle's law, and Charles' law. So there's a little video summary here that you can watch that's going to kind of give you a little background on all three of them and kind of talk about them, summarizing them. But I'm going to go ahead and I'm going to go over and we're going to look at each one. So I'm going to start with Boyle's law. Okay, so what you kind of need to know about Boyle's law is that it involves pressure and volume. So temperature and moles are constant. They do not change. So we're only looking at the relationship between pressure and volume. And in Boyle's law, what the evidence shows us is that they have what we call an inverse relationship. What that means is as one of the properties increases, the other decreases, or vice versa. So here it says as the volume decreases, the pressure increases. And if we think about what volume and pressure are, that makes sense, because I'm going to click on this little animation. And so what happens, you can see they're adding weights here, and it's shrinking the volume. Okay. So again, you can see it's shrinking the volume. And when the volume shrinks, you see this little pressure gauge is increasing. Okay. The temperature is not changing, and the number of particles, the moles of gas in here, are not changing. What's changing is as they shrink the volume, what happens as it gets smaller, there's less space for the particles to move around. And so just kind of by default, they're going to collide with the walls of the container more. And that's what pressure is. Remember, we talked last time about pressure is, actually, we talked last week about that pressure is caused by the particles colliding with the walls of the container. So the more collisions you have, the higher your pressure. And if you have a smaller space for the particles to move around, just kind of by design, by nature, they're going to collide more with the wall, which is going to increase your pressure. And then as the volume increases, you can see there's more space for them to move around, which means they're going to be doing less collisions, which means the pressure is going to decrease. And so we call that inverse because they're going opposite directions. And so when it's graphed, if you look over here on the right side, the graph kind of looks like this curve that's sloping downward, because like right here, I have a large volume on the y-axis, but I have a low number for the pressure on the x-axis. And then as my volume goes down, my pressure, so now I'm here on the y-axis, my volume is less, but if I go down to the x-axis for pressure, now the pressure is going to be a higher number. So when you see an inverse graph like this with this downward sloping curve, that's showing you an inverse relationship, and that's what the graph between pressure and volume would look like, okay? And so there's some more things down here. You can kind of look at the animations. There's some information you can click on here that really just kind of goes over what I kind of said about pressure and volume and how they relate. And then there's also another video down here that kind of shows how this applies in real life. And so free diving, people that dive without um, necessarily having certain equipment. This applies because as you go down in the water, the pressure is going to increase. And so that affects sort of the volumes, especially like the air in your lungs. And so they're going to show you using a bottle, they're going to show you what happens to the volume as the pressure increases and decreases. And so that same thing was going to be happening like in your lungs and things where there's air inside your body. All right, so our second one that we're going to look at is Charles's law. This one deals with temperature and volume. So in this one, pressure and moles of gas are constant. Okay, we're looking at the relationship between temperature and volume, and their relationship is what we call direct. Direct means that they're going to increase or decrease the same direction. So if the temperature increases, the volume is going to increase. If the temperature decreases, the volume is going to decrease. They move the same direction. So if I click on this, I can see that the graph, it's making a straight line with a positive slope. That's what the graph shape will look like if something has a direct relationship. Direct relationship means it's going to be a linear straight line with a positive slope, okay? And on the little animation, you can see here that right here, the temperature is going up and that's causing the volume to increase, okay? Now the temperature is going down, so it's kind of like they're adding this flame, they're heating it up, and the volume, it starts to expand, okay? It gets bigger. And so this is why a lot of times on things that have gas inside them, like canisters, they tell you to store it at a certain temperature because what happens is if the temperature gets too high, it's going to expand so much that it could burst and like pop your container open because the gas will need to escape because the volume cannot withstand that temperature. So again, kind of similar to the last one, there's some more explanation here on that relationship. And then here's sort of a real life application. Hot air balloons, because you're talking about, you have the hot air, you have the flame that's actually heating the air and that's causing it to expand, and that causes the balloon to rise. And so this is kind of a video for kids, so they don't use the term Charles law, but this is explaining the concept of Charles law in sort of a real life situation. All right. And then the last one is Avogadro's law. Okay. And so Avogadro's law, pressure and temperature are constant. What's changing is volume and the amount or the number of moles of gas. They also have a direct relationship. And so here in this container, I have fewer moles of gas, and so they're going to take up less space. If I have more moles of gas, usually they're going to take up more space. That kind of makes sense. So if I have equal volumes of gas at the same temperature and pressure, they're going to have equal number of particles. And so, if I, increase the number of moles, they're going to need more space, or they're going to take up more space. If I decrease it, they're going to take up less space. And so you can kind of think about this, if you're ever like airing up a tire in your car or like a basketball, or you're blowing up a balloon, you're adding more gas particles. If you blow up the balloon, you're blowing it up, and as you're blowing, you're adding more and more air. That's increasing the number of moles or the amount of gas particles. And so if you blow it up too much, what happens is it can burst, because it's going to keep filling up a larger and larger volume until it can't contain it anymore, and then it could burst. Same thing with like a car tire, or like a basketball or any kind of ball that you'd be airing up or something like that. And so again, here's a real life application. Again, the tire, okay? If this tire is deflated, and so really I just need to add more air. And so, a lot of times if you're in your car, sometimes you'll get that light that comes on that says like your tire pressure is low, the air in your tire is low. And usually you have to go stop like at a gas station or somewhere, and you have to add more air to it in order to reinflate it so that it's at the proper volume and pressure to be safe for you to drive. So kind of after that, on each page, kind of at the bottom, there are some little practice questions as you go through. So make sure you do those on each page. And then here at the end, there are a few questions at the end. I think there's 5 or 6 questions on this last page. So make sure that you're kind of reading and going through and answering those questions, as well as doing your notes and watching the little videos that are interspersed throughout. And then when you're completely finished, you can go to the last page and make sure that you have everything done, and you can submit your report for your grade for today. So last thing I want to show you guys really quick. So today is Wednesday. We just went over the gas laws lesson. And so Friday's a holiday. Okay. So Monday, when we come back for class, you guys just have your quiz. So when we get on Zoom on Monday, we probably will not be on for very long. I'll just be on in case there's any last minute questions or to kind of recap some stuff. And then you can take your quiz. If you want to take it before this week is over, that's completely fine. If you're done with all the lessons for the unit and you're like, I'm going to go ahead and take my quiz, you can do that. I will say it is it's already open, and it's actually open until the end of the 6 weeks next week on Friday. And it is, I'm trying to get it to load the directions. Okay. So you have 3 attempts, okay, just like on our last test, and you have an hour and a half once you start it. Okay. It has there's 11 total questions. Some of them are matching though, so there's 15 points, and then it'll convert it to a percentage for your grade for the grade book. Okay. So this quiz, that's your last grade for the 6 weeks. So those of you, if you are wondering like, what am I missing or what do I need to do? The grades that are in the grade book, we have the stuff from Unit 6. So I'll go back up here. So if you're still missing stuff from Unit 6, Unit 6, we had our test, okay? And then the other grades that were counted for this 6 weeks were the empirical and molecular formula calculation worksheet, the percent composition worksheet, and the mole conversion gizmos. So there's 3 assignments and the test from last unit, mole conversion gizmo, percent composition worksheet, and empirical molecular formula calculation worksheet. And then the Unit 6 test, those 4 grades from previous unit. And then you'll have 4 grades from this unit. You'll have your kinetic molecular theory lesson that you should have submitted after you completed the questions in it. You'll have the one that we just looked at on Monday on the intro to the gas relationships, where you did the sort of simulation, interacted and answered the questions and submitted that. And then you'll have today's lesson with the gas laws. And once you go through and do the practice questions, you can submit that. And then the last grade is going to be your quiz. So everything's already posted. So if you're somebody who likes to work ahead, you're welcome to do that. But just know that whatever we end up doing next week on like Wednesday and Friday, those grades are going to count for the new 6 weeks. Okay. So if you're trying to get caught up for the 6 weeks, you have 8 assignments. Okay. 1 test, 1 quiz. So 2 kind of major grades, and then 6 of the kind of daily assignment minor grades that you need to be working on getting caught up on. Okay.